Okay, so before discussing some example, let us recall some trig function values. Well, there are many ways to find trig function values. Well, you can use your trig function value table, or you can use device to find values, or you can use calculator. But sometimes you need to find trig function values quickly without any reference. And my favorite way is to use equilateral triangle with side 2. So we have equilateral triangle like this. So it has side 2, say triangle ABC. And you can pick midpoint D of the line segment BC. Then, of course, this line segment BD has length 1. Now that is equilateral triangle. This angle is obviously 60. Once you draw line segment AD, So once you draw this line segment, this bisects the angle A. So this angle is 30 degrees. And it also gives you two congruent right triangles, left side, right side. Let me fix this quickly. So we can use those right triangles to calculate, to find trig function values quickly. So look at the triangle, the left side triangle, A, B, D. You can calculate cosine 60. If you look at this triangle ABD, we have 1, 2, and Pythagorean theorem tells you this line segment is square root 3. It's like 1, 2, 3. So by definition, for this cosine value, you take ratio between AB and BD. So namely, BD over AB. And obviously, this is 1 over 2. And similarly, you can use this triangle to find sine 60 and tangent 60 and so on. So let me draw a table here. So angle 30, 45, 60. And then sine, cosine, tangent. So cosine 60 is 1/2. And then you can calculate the ratio between this hypotenuse and this AD to have sine 60, square root 3 over 2. And then tangent is the ratio between AD and BD. Okay, for this angle 30, you can rotate this right triangle ADC. So ADC so ADC. AD has length square root 3, DC has length 1, and AC is the hypotenuse 2. Again, it's like 1, 2, 3. And the angle is 30. So you can calculate sine 30, which is the ratio between this CD and AC. So 1/2. So sine 30 is 1/2. Again, you can use this triangle to find cosine 30, square root 3 over 2, and then tangent. Okay, for the remaining angle 45, we can use unit square with side 1. Once you draw diagonal like this angle is 45. And Pythagorean theorem tells you this hypotenuse is square root 2. So once you take upper triangle over lower triangle, you can calculate trig function values for 45 quickly. So square root 2 over 2, square root 2 over 2, and then 1. Well, it took some time to explain how we use those triangles, but once you get used to it, you can fill this table quickly without any reference. All right. By the way, let's remember those values for the following examples. So we'll be using those values, and let's remember cosine 60 is 1/2, sine 60 is square root 3 over 2, and tangent. All right, so quick example. So we are given some vector, and we want to represent this vector. So the vector has magnitude 2, and it makes an angle 60 from with the positive x-axis. So we are after this vector, and we want to find this coordinate, the coordinate of this terminal point. Once we find it, we can represent this vector. So the idea is, well, we recycle the right triangle in the previous page. We used half of equilateral triangle in the previous page. If you remember, the left side of the triangle is like this, right? And A, B, D. So we are recycling the right triangle that we used in the previous page. And from the labeling, well, this has magnitude 2. And now that it's a 60, you can tell this base has length 1. And then automatically, this height is square root 3. Good. So we find coordinate. So this terminal point is 1 comma square root 3. So this vector r is 1 comma square root 3. Good. We need to push this further to make nice and good observation. So the idea is to use magnitude. So we want to use this magnitude. Magnitude of this guy is 2. So you can rewrite like this, 2 times something. Actually, you're taking this 2 out. What's left is 1/2 and square root 3 over 2. Good. So once you take this out, you can express those components in terms of trig function. Especially you want to use the angle 60. Now you recall trig function values for this angle 60. And you know cosine 60 is nothing but 1/2. So this is cosine 60. And square root 3 over 2 is exactly sine 60. Look at this structure. Magnitude with trig function with the angle between this vector and positive x-axis. And actually, it turns out that every vector can be written in this way. Magnitude times cosine theta sine theta. Always. So let me formulate this. So say vector A has angle, say, theta, and like this. Well, the angle doesn't have to be less than 90 degrees. So this theta can be any angle. Suppose you have a vector like this, then this vector can be written magnitude with trig function values. again, this gives you magnitude, and this determines the direction. Actually, eventually you will see that this is actually a unit vector. So this observation 2 is a different version of observation 1. Every vector is completely determined by magnitude and direction.